Is that a shooting star through the night sky, or could that be a space debris flying by? There is so much space debris created by humans every year that eventually come back down through Earth's atmosphere. There are 160 million objects orbiting the Earth, creating real concern for spaceflight to move forth. The space debris can move at dizzying speeds of over 15,000 miles per hour. These are speeds that you can't see. Is there reason for concern? Does it affect humankind? It certainly does. Let's take a closer look to see what we find. If an astronaut's on the space station on a spacewalk to fix something at the space station to try and beat the clock, then a piece of space debris is orbiting through space. It could hit the astronaut, tearing a hole in his suit. Now brace. If you love the internet and rely on satellites, and a satellite is orbiting the Earth on its daily flight, a tiny piece of space debris traveling at dizzying speeds of 15,000 miles per hour on its path it proceeds. When it hits a satellite, it could damage it permanently, knocking out the internet with any size of the space debris. What is space junk and how does it come to be? Let's look at some examples as they fly by. We will see. This discarded launch vehicle is space junk. Also, this old discarded astronaut glove can create a funk. A dead space satellite is the trash I'm speaking of. Even tiny pieces of metal shot from mankind above. When the space debris continues to collide, creating more, we could create a Kessler effect, so space we can't explore. A Kessler effect is when space debris continues to collide, creating an endless debris field. No satellites survive, no spacecraft could leave the Earth to explore the universe. If we don't clear this junk, we'll be stuck on the surface of Earth. Is that a shooting star through the night sky, or could that be a space debris flying by? There is so much space debris created by humans every year that eventually come back down through Earth's atmosphere. We're astronomical objects brought to you here by size. Some within Neptune's orbit, others trans-Neptunian we fly. We're astronomical objects brought to you here by size. We all orbit the sun, that may come as some surprise. I'm Phoebe, an irregular satellite of Saturn IB. My alternative name is Saturn 9, you can see. Discovered in 1899 by William Pickering. My diameter is 213 kilometers while I do my thing. I'm 10199 Caraclo, an asteroid with rings, the largest confirmed small body of the outer solar system. I sing. I'm possibly a dwarf planet with a measured diameter of 232 kilometers, I'm sure. I'm 38628, Huya, a minor planet in your system, or trans-Neptunian object is my technical term as I'm spun. You can find me in the Kuiper Belt in the outer solar system. My diameter is 406 kilometers, how fun. I'm 2018 VG18 of this I am sure. A trans-Neptunian object, don't leave, there is more. First observed in 2018 by 3 astronomers. 500 kilometers is my known diameter. My name is Vesta, I'm a minor planet, you now know. I'm one of the largest objects in the asteroid belt. I do show I'm probably the second largest asteroid after Ceres. I have a mean diameter of 525 kilometers, you see. I'm 2014 UZ224, a trans-Neptunian object and possibly a dwarf planet, but the IAU hasn't decided yet. Out in the Kuiper Belt I was discovered, I am sure. 635 kilometers is my diameter. I'm 20,000 Varuna, a large trans-Neptunian object. In the Kuiper Belt I dwell in, possible dwarf but not yet. My elongated shape is due to my rapid rotation. 668 kilometers is my diameter, well spun. I am Ceres, I am a dwarf planet on the largest object in the main asteroid belt to orbit. I am too dim to be seen by the naked eye for sure. I am 946 kilometers in diameter. My name is Sedna, I am a minor around the sun. My surface is one of the reddest among the solar system objects. I'm 995 kilometers in diameter. Glad we met. My name is Quora, and I'm a dwarf planet candidate. But for now, I'm a non-resident trans-Neptunian object. I reside in the Kuiper Belt. It's so cold here, brr. And I'm 1110 kilometers in diameter. I'm 2007 OR10, that name it stood strong with the proposed name in 2019 of Gong Gong. My furthest distance is 9.4 billion miles from the sun. My diameter is 1230 kilometers as I run Namaki Maki, a minor planet I be. I'm perhaps the second largest object in the Kuiper Belt you see. I was discovered in 2005 by a team led by Michael Brown, and currently 1430 kilometers in diameter, and I'm round. Almea is my name, I'm a dwarf planet by fame. Beyond Neptune's orbit, you can find me with some aim. I'm the third largest known trans-Neptunian object. I'm 1632 kilometers in diameter, last I checked. My name is Ceres, I am a dwarf planet as well, and the second largest dwarf planet in the solar system. How swell! Located beyond the Kuiper Belt in a region called the scatter disk. My diameter in kilometers is 2326. I'm Pluto, I'm a big deal. As the largest dwarf planet, I used to be the ninth planet in the solar system till I quit. I am part of the cold and lonely Kuiper Belt. My diameter is 2376 kilometers, so I tell.
We're astronomical objects brought to you here by size. Some within Neptune's orbit, others trans-Neptunian we fly. We're astronomical objects brought to you here by size. We all orbit the sun, that may come as some surprise.
I'm the ISS, the International Space Station. 1998 was the year that begun my construction. I make multiple orbits around the Earth every day. Let's learn more about my history as we orbit in space. I fly around the world every 90 minutes. I orbit the Earth 16 times in 24 hours, that's legit. I'm 357 feet long from end to end. Am I? After the moon, I'm the second brightest object in your sky. I have 2 bathrooms on board, there's also 1 gym. I have 6 sleeping quarters and 6 spaceship docks for the win. Here's a brief history about how I came to be. Pay attention to my incredible collaborative construction story. The idea of the space station was science fiction until the 1940s. The structure might be built by many nations. In the 1950s, designs of spaceships and space stations began to develop. With the beginning of the space age, and it gained traction. The first rudimentary station was created in 1969 by the linking of 2 Russian Soyuz vehicles in line. In 1984, the US President Ronald Reagan told NASA to build the ISS for many nations. Then in 1998, the construction had begun of the only international space station. That year, the first segment of the ISS launched in November 20th by the Russian Proton rocket named Zarya. It's no myth. The Unity node from the US launched December 4th by the Space Shuttle Endeavour, set it on its course. The Endeavour met Zarya in orbit with the Unity node to make the first connection with the Russian segment, you know. In the year 2000, the first crew to man the space shuttle adrift was Bill Shepard, Yuri Gitsenko, and Sergei Krikalev. The US lab module was added in 2001. Then the European and Japanese lab joined in 2008, and we're not done. The ISS consists of 15 nations: Canada, Japan, and the Russian Federation, the United States, and the European Space Agency. They are Belgium, Denmark, France, Germany, and Italy, the Netherlands, Norway, Spain, and Sweden, Switzerland, and the famed United Kingdom. Maybe you will have the chance to visit me someday and be another part of the ISS and its history. I'm the ISS, the International Space Station. 1998 was the year that begun my construction. I make multiple orbits around the Earth every day. Let's learn more about my history as we orbit in space.
In the 1960s, we hope to go back soon. The Apollo missions were a NASA program and set a major spaceflight milestone for all humans. The Apollo program was conceived in 1960 during Dwight D. Eisenhower's presidency. Then the Apollo program started in 1961 and consisted of 11 total spaceflights and missions. Apollo was a NASA program that had American astronauts. Out of the 11 spaceflights, 6 of those resulted in moonwalks. The first 4 flights tested the equipment used in the Apollo program to see if astronauts could be sent to the moon and land. Apollo 1 attempted to launch in 1967. We lost 3 Apollo astronauts on this mission. Apollo 7 was launched in 1968 with a crew of 3. The times the crew orbited Earth was 163. Apollo 8 launched 1968 with a different crew of 3, and then the mission was also successful with Earth orbits numbering 10. Apollo 9 tested the lunar module in orbit in 69. The crew orbited the Earth 151 times. A rehearsal of the moon landing was in 69 on Apollo 10. It was a great success with 31 orbits around the Earth's bend. Apollo 11 was the first land and walk on the moon in 69. Neil Armstrong was the first to step foot on the moon for humankind. In 1969, Apollo 12 was the first precision landing on the moon, which was also successful instead of ending in doom. All astronauts survived on Apollo 13. You can see after an oxygen tank explosion in 1970. The Apollo 14 mission launched in 1971, which marked the first landing in the lunar highlands. This mission was done. The first use of the Apollo rover happened in 71 as well. This launched on Apollo 15 mission and it went real swell. Apollo 16 launched in 1972. Astronauts explored the lunar highlands. This is true. In 72, Apollo 17 was launched and nothing went wrong. This marks the last walk on the moon. Since then, no one has gone. You could visit space someday and our Earth you will see, or you could visit a different planet and make history. The Apollo mission brought humans to the moon. The first flight was in the 1960s. We hope to go back soon. We're the Hubble Space Telescope and the James Webb Telescope, that's me. We're here to tell you about us and what we can see. After decades of planning and research, I was finally finished and launched in 1990 as NASA had wished. I orbit 340 miles above Earth's surface to do my thing. Powered by solar power collected by my 2 solar-powered wings. I'm the length of a large school bus and weigh as much as 2 elephants, making more than 1 million observations while traveling 5 miles per second. I take sharp pictures of objects in the sky such as galaxies, planets, and stars and transmit them back to Earth for you to see. Earth's telescopes are blocked by the atmosphere to see light from space. I orbit above this atmosphere to give a clear view of my star chase. My achievements are pinning down the age of the universe, and I discovered 2 moons of Pluto, Nix, and Hydra, of course. I've helped determine the rate of which the universe is expanding in whole, and discovered nearly every major galaxy is anchored by a black hole. The James Webb Telescope is an infrared space observatory launched in 2021 for space exploration. You see, I'm here to probe the cosmos
cosmos and uncover the history of the universe, from the Big Bang and alien planet formation, and much more, of course. I'll take 30 days to travel a million miles to my home that's permanent, orbiting the sun, aligned with the Earth to explore space is my intent. When NASA built me, $10 billion was my cost. My impressive primary mirror is 6.5 meters across. It has 18 segments in a honeycomb structure, I say, and I am powered by an onboard solar array. The solar array provides me with 2,000 watts of electrical power and a propulsion system to maintain my observatory orbit by the hour. I have enough propellant on board to last 10 years of operation, to give a better understanding of the universe to every nation. I can see 13 billion light years back in time, which is 100 million years after the universe was born. I do refine. We're important because we give a view of space that is clear, orbiting above Earth's foggy atmosphere. We're the Hubble Space Telescope and the James Webb Telescope, that's me. We're here to tell you about us and what we can see.
I am the Earth, the only planet with organic life. With 8.7 million species, we all fight to survive. You all live on me, so work like bees in a hive, and keep this planet really healthy so that we can all thrive. My atmosphere is 78% nitrogen, another 21% of it is oxygen, and other small percentages of other elements. Without my atmosphere around, you would be frozen. I take 365 Earth days to orbit the sun. 24 hours makes one day, that's just one time that I'm spun. You won't fly off into space, gravity's pulling you down as fast as 9.8 meters a second towards the ground. I am the Earth, the only planet with organic life. With 8.7 million species, we all fight to survive. You all live on me, so work like bees in a hive, and keep this planet really healthy so that we can all thrive. There are 12 different types of climates that exist on me. Moderate, polar, dry, and tropical are 4 groups you see. Then there is continental, it is the 5th category. One climate in no group is highland, way above the sea. I'm the 3rd planet from the sun, no one is denser than me. My axis tilted 23.5, yeah, that's my degree. 4.5 billion years ago is when I was born, you see. I am the Earth, the only planet with organic life. With 8.7 million species, we all fight to survive. You all live on me, so work like bees in a hive, and keep this planet really healthy so that we can all thrive. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. I'm the crab pulsar, a young neutron star. I'm Calvera, an isolated neutron star that's far. My name's Vela X1, I'm a neutron star as well. Sirius B, that's me, a small white dwarf as you can tell. I'm EBLMJ0555-57AB. My name's TRAPPIST-1, an ultra cool red dwarf star in sight. I'm Proxima Centauri, a main sequence red dwarf star. I am your sun, a yellow dwarf that isn't too far. Alpha Centauri A is an orange star, you see. I
am Sirius, a main sequence star. That's me.
We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. VFTS 352, contact binary 1 and 2, composed of two very hot, bright, massive stars that orbit each other, it's true.
My name is Pollux, a red giant star here. Arcturus is a red giant star. I hope I made that clear. R136A1 is a Wolf Riot star thus far. I'm Aldebaran, a red giant star, that's me. Rigel is here, a blue-white supergiant you can see. I am Betelgeuse and I'm a red supergiant in class. VY Canis Majoris, a red hypergiant star with mass. I'm UI Scuti, the biggest red supergiant this far. Join us to sing the chorus, now get your head out of the stars.
We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go. We're all stars compared to each other by size. You can see a lot of us when you look into the night sky. We're all stars, our colors vary, you know. We're made mostly of hydrogen and helium, here we go.
I am the sun, the center of your solar system. I do erupt intense high energy radiation. This radiation I expel is called the solar flare. You'll learn about them in this song and why you should care. The sun is a ball of plasma, like an extremely hot ocean shaped like a wheel. This plasma is pushed around and shaped by the sun's magnetic field. When the sun's plasma swirls around by its magnetic field, it gets twisted and releases energy around sunspots, they are real. This energy released is caused by magnetic knots. When one of these knots breaks, it releases solar flares, so you are taught. Solar flares are waves of high energy radiation shot through the solar system in which we are all one. These solar flares race through space at the speed of light, creating a solar proton storm. These storms are no delight. When millions of tons of plasma are thrown from the sun's atmosphere, these storms are called coronal mass ejections, as you see right here. These CMEs reach speeds of 5.6 million miles per hour. When they hit Earth, it doesn't hurt living beings, even with such power. The Earth's atmosphere protects life from the biggest solar storms by absorbing the impact, so beings on the surface are safe from harm. When a CME is too big, it creates a solar superstorm that occur once or twice a century, so you've been warned. If a solar superstorm did happen in this day and age, it would shoot billions of tons of plasma from the sun, I do say. If this type of CME traveled across space towards the Earth, it would reach you in one day. Yeah, that's fast for what that is worth. Its shockwave would compress Earth's magnetic field, making it frail. The two magnetic fields would merge, stretching Earth's field into a thin tail. This stretched tail can't contain this energy anymore. When it snaps, it releases explosive energy towards the Earth that it stored. This creates something very rare called the geomagnetic storm. Normally no living thing on Earth would even know it had formed. The only thing it would affect is your electricity, because you rely on this so much it would disrupt human life, you see. Because Earth is covered in millions of electric wires and transformers, this geomagnetic storm would shut down the power, humans would be overturned. If one of these storms hit the Earth, electricity and internet would not work. All things powered by electricity would turn off along with all networks. Computers wouldn't work, along with phones and electronic devices. No refrigerators or any other household appliances. Even though we can't stop these terrible solar storms, their nasty side effects can be prevented by how we are warned. Engineers would have a day or two to unplug major power grids until the solar storm passes Earth, preventing blackouts we forbid. Humans need to prepare for these types of storms to prevent being thrown back to the Stone Age before they form. A cool event humans experience from any solar storm is the Aurora Borealis. At the two poles is where they perform. I'm the life-giving sun, you all need me to live, but I am unpredictable, so solar storms I give. I am the sun, the center of your solar system. I do erupt intense high energy radiation. This radiation I expel is called the solar flare. You'll learn about them in this song and why you should care.
Earth has four major geological subsystems. I will teach you in this song, I hope you learn and listen. Geosphere, atmosphere, Hydra Sphere, and biosphere are four major systems on Earth that balance why we survive here. These systems are all separate but interact with one another in so many different ways. In each system you will discover. Let's start with Geosphere, all Earth's materials and mass. It's comprised of all these parts that you'll be learning in my class. The solid iron inner core is a bit smaller than the moon. The nickel iron alloy outer core is liquid, it is true. The mantle is a layer between the crust and outer core, mostly made of minerals and silicate rock. Let's learn some more. Which brings us to the crust in which we all play and live on, made up of rock and lots of elements that keep it real strong. Earth has four major geological subsystems. I will teach you in this song, I hope you learn and listen. The atmosphere's the next sphere that we will look at. It contains Earth's air and protects all of us. Now how about that? The atmosphere's made up of 5 layers, now you know. One layer blocks radiation from the sun, it's called the ozone. Let's move on to the Hydra Sphere, it's a major one as well. It includes all forms of Earth's water, now isn't that swell? Oceans, lakes, and rivers, and our water vapor too, are what make up the Hydra Sphere. You learn something new. The biosphere's the final of the 4 major groups, including anything that's living, that also includes you. Microbes, animals, plants, birds, and insects alike are all part of the biosphere. That's true and it is alright. Earth has 4 major geological subsystems. I will teach you in this song, I hope you learn and listen. Here's one of many examples of how these spheres interact. There are so many different ways they help us live, and that's a fact. When volcanoes erupt from the geosphere, it releases particles and ash into the atmosphere. These particles act as the nuclei to help form water drops. That's the Hydra Sphere at work, and it never stops. When the rain falls to the earth, this is the Hydra Sphere, which stimulates plants to grow, which is the biosphere. The plants create oxygen that's released to the atmosphere. Plants also feed animals and humans, and that's biosphere. There's so many more examples you can find on your own. You can research them on your computer while sitting at home. Earth has 4 major geological subsystems. I will teach you in this song, I hope you learn and listen. Earth has 4 major geological subsystems. I will teach you in this song, I hope you learn and listen.
Here's the difference between these space rocks that you will see: asteroid, meteoroid, and comets, and some wood stages between. These different celestial bodies are important to learn. We're all part of this universe, let's give these space rocks their turn.
I'm an asteroid, also called a minor planet to some, a rocky airless remnant left over from our solar system's formation. You can find a lot of asteroids orbiting our sun, between Mars and Jupiter within the asteroid belt I run. I can range in size from about 329 miles down to 33 feet small. I've been here for a while. I'm made up of different kinds of rocks, and some have clays and metals, such as nickel and iron found in frying pans or kettles.
Here's the difference between these space rocks that you will see: asteroid, meteoroid, and comets, and some with stages between. These different celestial bodies are important to learn. We're all part of this universe. Let's give these space rocks their turn.
I'm a meteoroid. I'm smaller than an asteroid you see. My size can range from a grain of dust to a small asteroid. Yeah, that is me. I orbit the sun. I'm made of minerals called silicates, which is silicone and oxygen. I'm glad that you're learning this. I'm also made of heavier metals like nickel and iron. Let's go explore a little more about what other names I can become. If I enter Earth's atmosphere, you'll see a bright tail of light. If this happens and I vaporize, I'm called a meteor, that's right. Some call me a shooting or falling star. I'm only called a meteor if I burn up completely, it's bizarre. But if I make it through the atmosphere and reach the Earth's surface, my name changes to meteorite. That is important to learn this. I'm a comet, which is dust mixed with frozen gas. When fully frozen, I'm about the size of a small town. Through space I do pass. I'm made of ices like water, carbon dioxide, ammonia, and methane, mixed with cosmic dust from our solar system when it began. When I get close to the sun, I heat up and spew dust and gas. This forms a glowing tail that stretches away from the sun. As I pass, a cloud forms around my nucleus from my vaporizing ice. This is called a coma. It can expand 50,000 miles and it looks nice. My tail that formed can expand past 600,000 miles. Thank you for learning about all of us. I hope we made you smile.
Here's the difference between these space rocks that you will see: asteroid, meteoroid, and comets, and some with stages between. These different celestial bodies are important to learn. We're all part of this universe. Let's give these space rocks their turn. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I was first catalogued in 1860 by German astronomers at Bonn Observatory. I was named BD-125055 until my second survey. I was found to be slightly more bright. That's when I was named UI Scuti, the 38th variable star of the constellation Scutum am I. I'm the largest known star in the Milky Way Galaxy, but because I'm so far from Earth, you need a telescope to see me. I'm 30 times the sun's mass, but I have a radius more than 1,700 times greater than the Earth's sun I span. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I'm 9,500 light years away from your Earth. 1 light year equals about 5.88 trillion miles, for what that's worth. I'm known to be one of the most luminous stars, and I am a red supergiant. I hope you like me so far. I'm close to the supermassive black hole Sagittarius A, galactic center, which is the center of our galaxy. I'm so large, if you replaced your sun with me, my photosphere would span past Jupiter's orbit. As you can see, I've begun to fuse helium and continue to fuse hydrogen in the shell around my core, based on models of stellar evolution. After
fusing heavy elements, my core will begin to produce iron, disrupting the balance of gravity and radiation in its core, and resulting in a core collapse supernova, which is expected in stars like me. Look for me in the night sky within your galaxy. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. I am UI Scuti, the largest star in our galaxy. Find me in the night sky. I am UI Scuti, a red supergiant in the Scutum constellation am I. Let's talk about the Lithosphere and the 7 major tectonic plates. It's what shapes the face of the Earth with volcanoes and earthquakes. The lithosphere consists of the upper mantle and the crust. They're part of the geosphere on Earth, which makes these plates adjust. Tectonic plates are irregularly shaped slabs of solid rock, composed of oceanic and continental lithosphere bedrock. There are 3 tectonic boundaries running between tectonic plates. Divergent, convergent, and transform. Now aren't those names just great? Divergent boundaries move away from each other and produce rift valleys. Most active between oceanic plates, yes, the plates out in the sea. Convergent boundaries move toward one another and destructively collide. That's where you'd find those earthquakes and volcanoes do reside. Transform boundaries are 2 plates that slide past one another. The San Andreas Fault line's the best example of this to discover. Let's talk about the Lithosphere and the 7 major tectonic plates. It's what shapes the face of the Earth with volcanoes and earthquakes. Let's look at this topological map of the Earth that we live on. And the 7 major tectonic plates we're learning in this song. The biggest is the Pacific Plate. It lies beneath the Pacific Ocean, nicknamed the Ring of Fire due to all the volcanic commotion. The North American Plate is the next on the list of major plates. It includes both continental and oceanic crust, I indicate. Next we have the Eurasian Plate, also a major tectonic grate. 2 large continents, it includes our Europe and Asia today. Let's talk about the Lithosphere and the 7 major tectonic plates. It's what shapes the face of the Earth with volcanoes and earthquakes. Then the African Plate is next. It does straddle the vast equator. Most of Africa's continents in it, that's an easy way to locate her. The Antarctic Plate is a medium size of the 7 plates that are major. It houses the continent of Antarctica, you'll hear as I banter. The Indo-Australian Plate is on the smaller side of the majors. It's often considered 2 plates, but as one it's definitely much greater. The South American Plate is the smallest of the major plates, you know. That includes South America and Atlantic Ocean seabed below. Talk about the Lithosphere and the 7 major tectonic plates. It's what shapes the face of the Earth with volcanoes and earthquakes. Talk about the Lithosphere and the 7 major tectonic plates. It's what shapes the face of the Earth with volcanoes and earthquakes. This is a total solar eclipse. Come see my narrow path in which I travel on the Earth's surface. This is a total solar eclipse. My totality is awe-inspiring, so don't miss this. This celestial event is called a solar eclipse. Let me tell you about it so you can understand all this. A solar eclipse is caused by the moon, that is me. I pass in between the sun and the earth till black is what you see. Here are several stages and some visual tips that you can use to recognize a total solar eclipse. Stage 1 is called a partial eclipse. Is when the the sun's disk is partially blocked by the moon like this. Stage 2 is called Bailey's Beats, which are bright spots of light. It's when low-lying valleys on the moon's edge allow sunlight through, that's right. Stage 3 is sometimes called the diamond ring. This stage is key, in which marks the last few seconds before totality. The last bit of sunlight that is able to shine through the low-lying valleys creates a single flash of light on the side of the moon. The fourth and most important stage is called totality, when the moon completely covers the disk of the sun. This is what you see. Then comes the final stages, in which the sun will grow a crescent on the opposite side of the Bailey's beads, which once had shown. But before you see this celestial event, there's a few safety precautions for eye injuries to prevent. This is a total solar eclipse. Come see my narrow path in which I travel on the Earth's surface. This is a total solar eclipse. My totality is awe-inspiring, so don't miss this. On Monday, August 21st, 2017, there's a total solar eclipse North America will see. But the totality you wanna see can only be observed from Lincoln Beach, Oregon to Charleston, South Carolina, so I've heard. The path of totality is 70 miles wide, they say, seen in 14 states in the continental US of A. Totality lasts a few minutes, so be sure to be there, and please use special safety glasses so your vision isn't impaired. You can buy these special solar eclipse glasses online, so protect your eyes from the sun while having a great time. This is a total solar eclipse. Come see my narrow path in which I travel on the Earth's surface. This is a total solar eclipse. My totality is awe-inspiring, so don't miss this. A solar eclipse has several areas we need to discuss. Take a look at this picture to learn each part is a must. Here's the penumbra, a partially shaded outer region surrounding the umbra, a fully shaded inner part that's darkened. A partial eclipse is what you're seeing right here, when only part of the luminary of a celestial body is darkened there. This is a total eclipse, it's red on your screen. It's when the whole of the disk of the sun is covered, that's what it means. This is a total solar eclipse. Come see my narrow path in which I travel on the Earth's surface. This is a total solar eclipse. My totality is awe-inspiring, so don't miss this. Here's a theory of how the Earth was formed, so scientists would say this interstellar journey will show you the role gravity had played. Almost 5 billion years ago, there was only our sun, which was a newborn star surrounded by dust, was how it begun. Over time, this dust began to slam into one another due to gravity pulling it in as it smashed into each other. The planet that we live on was made by space dust and rocks that formed Earth over millions of years into an orb, not a box. They say 4.5 billion years ago, Earth was a fireball. That's right, with surface temperatures over 2,000 degrees in Fahrenheit. At this point, there was no air, just carbon dioxide, nitrogen, and water vapor, making it hot and toxic when the Earth began. Our boiling ball of liquid rock was slammed by a young planet. This planet's name was Theia. It was the size of Mars as you see it. The blast wave from this collision sent trillions of tons of debris, which over time was pulled back in to circle the Earth by gravity. This giant ring around the Earth was made of red hot dust and rock, eventually formed our moon we see today. I know it's a shock. Let's speed up millions of years to see how water formed. About 3.9 billion years ago, Earth was hit by a meteor storm. Inside each meteor, scientists think there were small crystals. Each crystal held tiny droplets of water inside their shells. Over the 20 million years that these meteors fell, pools of water started to form on the cooling crust. I do tell, all water on our Earth is billions of years old now, you see, and may have traveled millions of miles to be consumed by you and me. Let's speed up hundreds of millions of years to find the Earth covered in water, with tiny islands peeking out while the core remained much hotter. This magma's hot core pushes molten rock up and out the Earth's new crust. When the lava cools, it forms a land we know as it builds and thrusts. Over time, these land masses start to collide and eventually form our continents we know today do still transform. Here's a theory of how the Earth was formed, so scientists would say this interstellar journey will show you the role gravity had played. How did Earth get its atmosphere we have today? There are three basic atmospheric hypotheses still used to this day. The first atmosphere was made up of hydrogen and helium gas. These molecules move so fast they escape Earth's gravity into space at last. The second was made of lots of volcanoes releasing water as steam and carbon dioxide, hydrogen sulfate, ammonia, and methane. Science agreed. The third and current atmosphere is made up of this. You will see plants take in carbon dioxide and give off oxygen to you and me. All animals take in oxygen and give off CO2. Also volcanoes and burning stuff produces this like fossil fuels. We burn too many fossil fuels and have too many factory farms. All this carbon dioxide we produce is doing our Earth harm. It's up to us to change the way we consume and create energy. If you start to make changes now, our planet will change, you will see. Please do your part to save the Earth, to improve your future now. We're capable of change, go make us all proud. Here's a theory of how the Earth was formed, so scientists would say this interstellar journey will show you the role gravity had played. You're so smart and important, so believe in what you can do. Make a change and set the stage in Earth's future for you.
There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Mercury. I'm the second hottest planet, but the closest one to the sun. A year on my surface is 88 days. I'm the smallest but lots of fun.
My name is Venus. I'm the hottest planet, but the second planet from the sun. I'm the brightest planet in our solar system, and I'm too hot for anyone. My name is Earth. I'm the planet you live on, and the third planet from the sun. I'm the only planet with organic life, so take care of me, 'cause we're all one. There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name is Mars. I am red in color and the 4th planet from the sun. I have the highest mountain in our solar system, a volcano named Olympus Mons. My name is Jupiter. I am covered in clouds and I'm the 5th planet from the sun. My giant red spot is a raging storm. As for size, I'm the biggest one. My name is Saturn. I am brown in color. I'm the 6th planet from the sun. My outer rings are extremely thin. They're made of dust and icy chunks. There are 8 planets in the solar system, and we revolve around the sun. Join us to learn about the different planets. Now sing along and have some fun. My name's Uranus. I am blue in color. I'm the 7th planet from the sun. I orbit the sun once in 84 Earth years and was discovered in 1781. My name is Neptune, also blue in color. I'm the 8th planet from the sun. I'm the last gas giant in our solar system, and I'm also the coldest one. There are 8 planets in the solar system.
Now sing along and have some fun. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes.
I'm a molecular cloud, I'm a type of nebula. I have a high density and a very low temperature. This combination creates a gas molecular hydrogen. That's primarily what I'm made of, along with cosmic dust within. When the force of gravity exceeds the outward push of gas, the pressure is so great that I can't help it and start to collapse, which is caused from a shockwave from a near exploding star, or when two molecular clouds collide. Now isn't that bizarre? When the gravity's too strong, I break apart into smaller clouds. Each cloud is a star's beginning, in which I am very proud. Protostars are the name of the clouds that do break free. Let me introduce a protostar that was a part of me. Hello there, I'm the beginning of any kind of star. Let me introduce myself to you. I am a protostar. My core is not hot enough for fusion to occur. To achieve that level of stardom, that process is a chore. The first thing I do when I break free from my molecular cloud, I start to spin until I form this disk around me you see now. As the disk rotates, I produce a strong magnetic field, pulling gas and dust into my center core as I reveal. The infalling gas releases a kinetic energy, creating heat, increasing the temperature in the center of me. At this point, I can transform into a hydrogen burning star, which is when the nuclear fusion starts in a protostar. This is when I cross over to stage 3 called Tectonic. We play our different roles in the star formation you see.
This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes.
I'm a Tectonic star now, also a pre-made sequence star. My job's to clear away the dust and gas and send it really far. My stellar winds create bipolar outflows that decrease my mass, till I'm a main sequence star, my center burning nuclear gas. Now I'm a main sequence star, now just like the sun, you know. For billions of years I will burn throughout my light show. Converting hydrogen to helium is how fusion exists. It wants to blow me apart but has a hard time doing this. Cause of gravity of equal power pushing me in, I'm able to stay burning since the fusion did begin. There are many different kinds of stars throughout the universe. Go learn about them all now that you know how they are birthed.
This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. This is the stellar evolution of a star in the universe. A nebula is the beginning of a star before its birth. The star names you will encounter are some basic different stages in the evolution of a star and all its basic changes. I am the Milky Way Galaxy. Look in the night sky to see a part of me. I am the Milky Way Galaxy. Your solar system's just a tiny part of me. The Milky Way name came from a Greek goddess named Hera, who spilled milk across the sky. Greeks believed in that era. When you look at the darkest sky on a clear summer night, and you see the image of the Milky Way clear in sight, remember you can only see a small part of me, called the galactic core in my galaxy. Astronomers can't look at me from outside the galaxy, because I'm so massive and you don't have the technology. Based on other galaxies we see outside of our own, is why we conclude that our galaxy spiral
world as I'm shown. When you look at a side view of the Milky Way here, you see me as a flat disk with a bulge center. I appear.
I am the Milky Way Galaxy. Look in the night sky to see a part of me. I am the Milky Way Galaxy. Your solar system's just a tiny part of me.
I was born about 13.6 billion years ago. That's a hypothesis given from astronomers, though. I am 100,000 light years in diameter. That's an estimate given by NASA, though they can't be sure. Your solar system's this tiny dot that you see right here. Astronomers think that Orion spurs where your system appears. Your system's guessed to be 25,000 light years from the galactic center of the Milky Way shown here. About 230 million years is what your system takes to orbit around the Milky Way center's cool shape. 200 to 400 billion stars live in me. That's an estimate only based on our astronomy. Over 100 billion planets might exist in me. Maybe someday you can see them in our galaxy.
I am the Milky Way Galaxy. Look in the night sky to see a part of me. I am the Milky Way Galaxy. Your solar system's just a tiny part of me. Let's take a look at all the parts that you think I'm made of. We'll start by looking down at the galaxy above. The galactic core's the rotational center you can't see. Because of the interstellar dust, it cannot be studied. It's believed the center is a supermassive black hole. When astronomers find out more, then I will let you know. You'll notice the galactic bar and also the long bar. There's the 3 kpc arms, there is a near and there's a far. Then we have the Sagittarius and the Norma arms. Then the Orion Sphere, where your solar system spins on. The Scutum Centaurus and Perseus arm are 2 major spirals and full of the galaxy's charm. Finally, the outer arm and the new outer arm are the final spirals I will mention in this song. I am the Milky Way Galaxy. Look in the night sky to see a part of me. I am the Milky Way Galaxy. Your solar system's just a tiny part of me. I am the Milky Way Galaxy. Look in the night sky to see a part of me. I am the Milky Way Galaxy. Your solar system's just a tiny part of me.
I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. All of the planets in our solar system, they orbit while they follow me. 230 million years is the time I take to fly around the Milky Way Galaxy. I don't have a solid surface, I'm made up of gases held together by my own gravity. I'm made of 92.1% hydrogen H2 and 7.8% helium He. I'm a star called the sun. I'm the center of our solar system. You revolve around me as we fly around the galaxy. My core is 25% of my total mass and 27 million degrees. My energy is the reason there is life on Earth. There'll be no charge cause I'm totally free. My mass makes up 99.8% of our
solar system. Nothing in our system's hot as me. I'm a star called the sun. I'm the center